Hello everyone and welcome to another episode in this series on how to make a third-person shooter. Now, the past two episodes we managed to create our character, import its animation, set up a basic state machine, and in the last episode we created the camera structure that I promise is going to come in very useful this episode. Now, finally, it's time to control where our character is going. And the reason I waited till the end to do this is because in third-person shooter, character movement is very dependent on both the camera and also the animation and where the character is facing. So it's just much easier to wait till now to implement all the little quirks of moving a character in 3D. And to be honest, controls are the stuff that usually require the most polish. For example, if we go back in the camera script that we did the last episode, we set up a basic unhandled input to rotate the camera around the player, and I mentioned that I was just dividing by 100 to set the sensitivity of the rotation of the player. But the truth is, this sensitivity, you can tweak it as much as you want, but usually you'll want it dynamic for a bunch of reasons. For example, when the character is running, maybe you want the rotation to be a little bit slower, so you want the sensitivity higher or lower. And of course, you want this to be a setting so that the player can change their preference depending on what kind of mouse they're using or something. But on console, wow, that's even worse, because on console then it's based on how far the player is pushing the stick. But not only that, when you're turning around the character, the yaw is actually 360 degrees, but the up and down, the pitch, is actually limited. We put some limit, like minus 45 degree to plus 80 degree, I think, which would be like 125 degrees of freedom. So actually you have much less freedom in pitch than in yaw. So if your sensitivity is the same in pitch and in yaw, it's gonna feel like it takes much longer to turn around the character than to hit the limit of up and down. So you might want to tweak the sensitivity independently of the pitch and the yaw. But for now, let's go back into our character script, because in third-person shooter, the character moves based on where the camera is looking. That means we need to have a reference to our camera. Now, if you remember, we also have a reference to our character in the camera. And we're lucky that Godot doesn't mind, because in some languages this can actually be a cause of cyclic dependencies. But thankfully this is not C++, so we can just easily reference each of their script, and it's gonna work just fine. Now, before we can implement all of these moves inside the physics process, we are going to go into our project setting, our input map, and we're going to add the keys we're going to be needing. So we can add a forward, backward, left, right, jump, and sprint. And for the keys, I'm right now going to just add the classic WASD. And for the jump, I'm going to set the spacebar, and for the sprint, I'm going to use shift. Now that we have these keys, we also need to go back into our character scene, and we have to improve our animation tree a little bit. So if you remember, we have the idle, running, and walking, and transition between them. Now I have these two jumps. I actually have this running jump, we will call it. And we have this kind of standing jump. And I couldn't find a good walking jump, but it doesn't matter because it would be the same thing. For walking, I'm just not gonna add it for now. And of course, ideally, I would have liked to have 3 animation so that I can split the jump into jump up, jump down, and in the air, so that, for example, when the character is falling, I can just play the in the air until he hits the ground, and then I can play the landing animation. But I don't have that for now, so it's gonna have to do. So we're just going to add some transition. The standing jump is going to go with the idle, and the running jump is going to be here. Now the transitions are going to be a little bit different this time, because here I just transition whenever, wherever. But in the case of a jump, the jump can start anytime. We're still going to add a little bit of fade. But in the case of the jump, I want it to always play till the end before going back into the running. So what I'm going to do is say that the transition is at the end, and I'm going to select auto advance. So now I can play the run, and if I tell it to jump, it's going to jump, and then it's going to go back to the running. And I didn't add any fading, so it's a little bit abrupt. So we're going to put a bit of fading, and we can test again. And we see that after he jumps, he goes back automatically into running. I'm going to set up something similar for the idle. So we want at the end, we want a little bit of fade. And we want a little bit here too. So that when we're in idle, we go to a standing jump, and then he goes back into, I forgot the auto advance. So he jumps, and then he goes back into idle. Now, the interesting part is that I don't want to care about where I am when I'm jumping. I don't want to have to say, if you're running, go into running jump, and if you're idle, go into idle jump. There's a way to do that I just figured out. You can put an advanced condition, and this, if the condition is true, is going to automatically transition to this. So I'm going to have this called jump, and this, as the documentation says, is going to create a parameter, the name that you set it, and it's going to be a Boolean, and if the Boolean is true, then the transition is going to happen. And I'm going to do and set the same name for the standing jump. This way, instead of telling the state machine to travel to a specific node, I'm just going to set the jump, and if this state is allowed to jump, then it's going to transition to this jump. So now we can go back into our script, and if you remember in the physics process, this is where we were setting the animation, but we can just get rid of this part. We're going to keep the get root motion and everything, and we're going to start handling the actual movement of our character. Now, the first thing to consider is that in its local space, the character is always pointing towards the Z positive. So what we're going to do is declare this direction vector and we are going to use the input we define to decide where the character should be moving. So if we're pressing forward, like I said, in the local space, forward is Z positive. So we're going to increment our Z by 1. And if we want to go backward, we're going to decrease our Z by 1. And we're going to do exactly the same thing for left and right, but if forward is Z, then left and right is X plus and minus. So we're going to set X here, and this is going to be left and right. Now I'm setting it to plus minus 1, but if you had a console controller, you could just use directly the input from the controller, which means you would have to handle the case where it's not absolutely 0 or 1. You could do this by setting the animation speed, or you could automatically trigger the run past a certain point or something. But again, this is something that opens a whole can of worms that I'm not going to get into right now. But once we have our direction, we can check if this direction is bigger than a certain amount. If it's not 0, basically, it means that we want to move. And if we want to move, we have to decide which direction we're going to go. But this direction is not local to the character. It's based on where the camera is looking. So what we're going to do is rotate this direction based on our camera data that we have from the previous episode. So in this case, I'm really only interested in the yaw of the camera. I don't care how up and down it's looking. So what I'm going to do is fetch just the yaw from the rotation in our camera setup. Now we have the actual heading we want the character to go, but we need to calculate how to rotate the character to this heading. So now I'm going to calculate the current player heading in 2D, because again, I'm only really interested in the yaw, and I can do this by getting the basis from the transform of the character X and the transform basis of the character Z. And now the other thing I can do is calculate the desired heading based on the direction we just calculated. And again, I'm going to convert this in 2D so that it's going to be on a plane. And now that I have this, I can calculate the angle between those two headings so that I know what rotation to apply to my character. And I do this by using angle 2, player heading, and desired heading. And then I can just set the rotation of the character to that heading. Another thing to notice is that the root motion transform I was getting from the previous episode is actually in local space. So if I want the character to move in the proper direction, if I'm rotating the character, I have to also rotate the velocity. So I'm going to rotate the velocity by the rotation of the player. Finally, we have to travel the animation just like we were doing before. So in this case, I'm going to check the input that's pressed, and if the sprint button is pressed, then I'm going to travel to the running state, just like we were doing before. And if the sprint is not pressed, then I'm going to travel to the walking animation. Now the last piece is if the direction is 0, it means we're not pushing anything and we want the character to go back to his idle state. So I'm going to have an else here and go to idle. That said, when we're transitioning between running and idle or walking and idle, if you remember, I put a transition time, which means the character is going to keep moving a little bit while it's transitioning. So I need to keep the heading applied just like I did here. So I'm actually going to apply this to the velocity here. And of course, at the end, we have our move and slide again to move the character. Now, if I test this, as you can see, we can move the character forward, backward, left, and right. And if we hold shift, we can make him run, and we can drag the camera to make him look around. But as you can see, moving left and right or back and front, the change is a little bit abrupt, maybe. It's a little bit too much. So that's why I calculated a difference of heading, because I can take the phi we calculated before and I can calculate a fraction of it that I want to be the maximum rotation speed of the character. And by just doing this now, if I start the game again, you're going to notice that the character smoothly turns back and forth, back and forth. Of course, it means that, for example, when I'm running and I look right or left, the character takes a little bit more time than the camera to rotate. And usually that's what you want. Of course, you want to fiddle with those settings again. Once again, this rotation, max rotation speed, if you will, is something that usually you have to spend a lot of time to polish. And on console especially, there's going to be a lot of rules about how much you want to tweak this value dynamically. But for now, that's going to do. Now, if we start the game again, and we were to, say, walk next to one of those walls, you'll notice that the camera doesn't really care about the wall, which is going to be quite shocking in most scenarios. So to add a bit of collision, we could try to make the camera physical by giving it a rigid body or something like that. But the problem with this is that it's going to be very hard to predict where the camera is going to go if we enable some sort of collision. Really, we want to all the time keep complete control of what the camera is doing. So the best way to do it is actually to go back into our camera script, and after the process function, we're going to call a new method that we're going to call collide, and we're going to define this method. And what we're going to do is just a simple raycast between the character and the camera, and we're going to put the camera along its pole wherever the collision occurs. Of course, we're going to leave the camera where it is if there's no collision. To do this, we just calculate the starting point as the origin of the character without forgetting the anchor offset that we set in the previous episode. And we calculate the endpoint to be the actual position of the camera. Since we're doing this after we've set everything, the camera should be at its normal position. Then we have to get the space state, which is what we need to cast raycast. And we do this by getting the world and getting the direct space state. That's hard to say. And then we go and try to do a raycast and see what happened. And if there is a collision, then we get the collision point and we set the camera on this collision point. And remember, since our ray is exactly in line with the pole of our camera, all we're doing is moving the camera back and forth along the pole that we already set, which means that if it's set in a way that makes sense, the camera should move, well, at least a little bit okay-ish way. Because, of course, if you're really close to a wall, then, you know, the collision's gonna end up inside the character or something, and it's gonna be messy. But for now, this should be good enough for 99.9% of the case. So if I go back to my wall here, as you can see, the camera is gonna snap to the collision of the wall without intersecting with the wall. You could give it a little bit more offset, for example, if you want to make sure that you never, ever, ever see stuff like this here. And you might want to put a small smoothing. You know, you sacrifice a little bit of intersection with the object so that the camera doesn't snap like all the time like it's doing right now. There's many ways to fix these kind of things, but there isn't like one simple solution. It's a bunch of different things. And, you know, people all the time complain about third-person camera and how they handle, and that's because it's really not that easy. But all of this is polish that you can do later. This is going to be okay for 99.9% of all the cases. Now, we still haven't added jumping, but that's something that's going to be very easy because of the way we set up our animation tree. If you remember, we created this variable in the transition in the advanced condition called jump. And because we've already set all the transition and stuff in the animation tree, and we've already told the game what is allowed and what isn't allowed, all we have to do really is in the anim tree set the parameters slash, what was the name? Condition slash jump to the value of our action pressed jump. If you're in a state where you cannot jump, or if you're already jumping, then this is not going to do anything. If you're in the running state, then this transition is going to trigger. And by just doing this, we should have jumping now. So when we're idle, we should be able to jump. And when we're running, we should be able to jump over obstacle. Of course, all of this is just the base for a third-person shooter. I mean, we haven't even handled the shooting or the gun holding or all of this. But with what I've shown you, you should be able to take this knowledge and apply it to additive animation or gun handling or targeting or stuff like that. Also, we programmed everything in the camera in the process method, but that's a pretty bad idea. If you're going to have a fairly complex game, you should think about how you're going to structure all the different moving parts of your camera. One of the way I like to think about it is applying effects on top of each other. So I could have like a shake effect being applied on top of the basic camera movement, or I could have an animation effect, and I can even layer an animation and a shake on top of each other, for example, and they just apply this to the camera structure data. This camera structure is also nice because you can have multiple structure. You can even save them on disk, so you can have debug camera setup, you can have multiple camera setup, and you can always interpolate the values between those setup so that you can have smooth transition. So these are all things you should consider, but you have the basic setup to do all of this. Similarly, in the player controls, there's a lot of things you could tweak and smooth and improve, especially on console. There's all sorts of things you want to do to help the player manipulate the character with the controller. But this is all stuff you're going to have to research on your own based on what kind of game you want to make and what your goal is in the end. So that's going to be it for this series. Thank you very much for watching. I hope you enjoy it. Don't forget to leave a comment, a like, subscribe maybe for another series like that, and see you all in my next episode. Bye!